Oh, mama, love me. It's running on and on.
Well, welcome back to Dad's shed. This time we're at the other end, the bench end, at least for the present time, to explain what I'm doing. And it's actually taking the shed back to the real reason for its existence, which is my model steam locomotive. I decided earlier this year that I would get it running again, as my elder son hasn't actually seen it working. So I got it out, started doing some checking over on it, and I found that the regulator, which is basically the valve that allows steam from the boiler through to the cylinders, was seized. So with my 7-year-old son's help, because his fingers are much smaller than mine, can get inside, we took it apart, took the boiler off, I took the dome off, accessed the regulator and sorted the problem out. However, as usually happens when you have a relatively simple job, things then occur which you didn't quite expect. And I will say here that the last time I steamed it, it was a bit shy of steam when trying to actually pull a train. Sitting still, steaming up, no problem, safety valves would lift, steamed beautifully. But once you get it running, pressure starts dropping. There was no obvious reason. However, having taken it apart, I found some residue in the bottom of the smoke box and around the soup heater element, which said to me that there was a steam leak. So that, and I'll explain why that is for anyone who doesn't understand steam locomotives. The smoke box has a vacuum in it created by the blast pipe, and that sucks the air through the fire, makes it burn hot enough to melt a steel shovel if you're silly enough to leave it in there. But that vacuum is absolutely vital to the fire working properly, and any steam leak at that end will destroy the vacuum, at least partially, so it will then not steam anywhere near as well as it should. So not a problem. This is held in by a header. So what you've got is, in the boiler, you've got the main steam pipe that goes from the output side of the regulator valve to the end of the boiler barrel. That then goes into a fitting, which is screwed on the inside for the main steam pipe, on the outside to fit into the bush in the boiler barrel. And then the wet header bolts, and in my case on 5 bolts, to the front of that, down the 4 pipes, into the soup heater elements, back out into the dry header, and then down to the cylinders. So I pulled this out and I've re-brazed the pipe into the outer tube. So not a problem. But while I was looking at it, I thought, sure there shouldn't be gaps that big there. And the way this is made is you've got a stainless steel outer sheath, which is sealed and brazed and welded at the far end. Copper tube into it, and then a copper tube coaxial to it that runs down the middle and is sealed at the end, and then into the dry header. And these are silver soldered up or brazed up, and they should not do this. Bit of an issue. But also I found that this item, which is the header, and I've cut it off, it was very badly made by me in the first place, This was one of the early things I made, and I've learnt a lot since then. This is about 30 years old. But that's drilled far too close to the outside edge, and the threads were really close, and over the years they've actually now come through, so you can actually see through the side of that. Again, not good if you're trying to seal it against steam pressure. So that's going to have to be remade. I'm going to do it differently because this was brazed in place, so I'm going to alter this. I'm going to make some fittings so I can screw this to the wet header. So I'll remake the wet header, remake the connections on the end of this. I'm going to have to re-solder all these pieces. So a really simple job has turned into a lot of work. So I've got to clean all this up now, try and get it back to a situation where I can re-braze it. Then I will want to remake these, so I'll cut these back, the pipes here. I'll make a fitting to go on the end, which will have a shouldered nut, which will then attach it to some threaded fittings on the bottom of the wet header that I'm going to manufacture. So that's going to be an interesting mix. It's going to be silver soldering or brazing, it's going to be milling, screw cutting, although that will probably be done with a die, making some fairly small fittings to braze onto the end of these, and then trying to get it all to fit. So that's what this little project is going to be about. It will probably be done in a couple of parts because it's going to take some fair while to get anywhere with it. So the other thing I've got to bear in mind is that this header has actually got a screw hole in the top of it. It takes this, and this is what is called the snifting valve. Now the snifting valve is an anti-vacuum valve, and this has got 8 holes drilled in the periphery. That goes into a central chamber, and that chamber is sealed when there is steam pressure by a ball bearing that just pushes up and sits in the hole. When there is no steam pressure, the ball bearing drops and allows clearance for air to be drawn in through these holes, and it makes an interesting clack noise when it seats. So that's a snifting valve, but that means that the new wet header will need to have the hole drilled in the top in the right place, because that goes through the smokebox shell and straight into it. So a number of issues here, a little bit of a challenge. Let's get on and do something. Well, back on the bench again, I now need to work out the approximate width I need to make the new dry header. So if I move that across there, and that will come up here, so that will be about that sort of width. So that will give me a little bit to play with. Right, so I've actually got 5/16 model engineer thread at 32 threads per inch. So that takes a 7.1mm drill, and as I've actually gone through at 6.9, let's take a little bit out of the end there, ready to get the tap going through. Okay, so that's drilled more than the depth I need. So, hand pressure on the tailstock, turn this over by hand. So one of the great advantages of the Myford series lathes is that you can open this up and just pull it through by hand. Doesn't work very well if you're doing something like 1/2 inch Whitworth, but for something like this, especially in bronze or brass. And just like that, I've got the thread done. Now all I need to do is take that out. Take the workpiece out, turn it around, there we go. If I actually go here, grab this drill, and that takes you down to that line there. So if I push the drill in to the end, my fingernail there, that takes it smack to the second line I put on. So I now know as long as I don't go down to there when I'm facing the end, I've got plenty of room. So that's the basis of this now done. Take the edges off the ends where it's been turned down. I know I've got about 3 mil at that end between the end of the hole and the end of the bar, and I need to just measure that to get the length accurate. Put a hole in the middle and then 2 holes on the other side, either side of that, ready to take the fixings for the steam pipes. So let's crack on and do some of that. So I've worked out from the pipework that's in existence already the sizes I need, and it just about gives me the bits that I need and the size that I want. I could go up a size, but then it makes clearance very, very difficult. So I'm using a 3/8 by 32 thread per inch screw thread. It's the Model Engineer standard, so Whitworth thread form. And what I'm doing here is just taking this piece of brass, which is 3/8 diameter, and I'm making the screw fittings to take the superheater header. That's the OD of the thread anyway, so I'm not going to bother about turning that down. I will drill through at 5mm, which is the clearance size for the inside of the pipework. Put a nice deep countersink in the end. I'll then use my die, which is sitting in one of these. It's a die holder. That will go in the tailstock, and that will enable me to get it lined up pretty well. I actually have made quite a few of these. One I bought many years ago. It's been very useful, but I've made some others which are a slight improvement on it, in that I can get 5/8 threads through. This is limited to 1/2 inch, but that's more than enough for today. So I'll drill through. I'll use the tailstock die holder to cut the thread. I'll then use a parting tool to go plunge cut in and take that down to 7mm. That will then fit in the holes I'm going to drill, or have drilled, in the bottom of the wet header. So let's crack on and do some turning. Okay, so let's start off by doing the nipples, if you like, that will go onto the end of the copper tube. I had a good look around, and the nearest size I could find to do the union nuts is 1/2 inch OD, across flats rather, and what I could really do with is 7/16. So I've got some on order, but it won't be here for a couple of days, so I may as well get on and do this. So let's just drill through 5mm, and then I'll follow that up with a 6.7mm. Then I'll turn down a short shoulder on the back to 7.5mm. The whole outside diameter will be turned down to 8.6, and that will go in down the core of the thread, which is 3/8, and there'll be a short 1/2mm shoulder all the way round that it will then sit against and hold in. So let's drill some holes. Okay, that's not too bad. Let's take this up a bit on speed and do a little bit of a shoulder. I think what I'm going to do, let's be sensible about this. Take that in, stop the deflection. What do I need? 8.6. 9.2. .58, which is almost dead on. No, it's not. Yeah, 8.58, 8.6. So let's zero that. Okay, so there's the 4 olives, or the nipples, ready to be soldered on, well, tidied up a little bit at the end on the stone. but they're now drilled out, ready to be put onto the tubes. But I can't do that until I've made the union nuts, because it would be a bit silly to silver solder those into position and then discover the nuts aren't in place behind them. So they'll be sitting around now until my 7/16 brass hex bar arrives, which should be another couple of days. And once I've done that, I can turn up the union nuts and get on with putting the whole thing together. Welcome. I've now got the material I need to do the union nuts for this little project. Arrived the other day, but unfortunately I've been on night shift, so I haven't been able to do anything. It's 7/16 brass rod. Now I've done a little bit of measuring and calculation. I need to drill into here 5mm, and excuse me for mixing the measurements that I'm using. I've got to drill in here 5mm with an 8.8mm bit. I drill through at 7.4mm, and then I follow up with a flat ended drill, which I've modified from a previously modified drill. I tend to buy a lot of drills at boot sales and other places, not for drilling specific stuff, but they're always useful to have around as a standby if you need to do anything odd. So that was a very cheap drill, probably cost me about 10p, but I put it on the grinder and I ground the end flat. It actually came to me with something like a 60-degree point on it, so it's now a flat end. So that will give me a flat bottom in the hole. I've then got my 3/8 by 32 Model Engineer tap to go in there, and then what I will do is I will finish off by drilling back through again with the 7.4 to clear any burrs in the hole, and then I'll part it off. So that's about the plan. So I suppose we better get on and do something. First off is going to be centering it. So stick the centre drill in, move that back out of the way. I'm just going to tighten that up a little bit. That seems to be moving in there. I'm running this a little bit slower than I would normally, but there is a basic reason for that. It's called laziness. I don't want to just keep changing the speeds all the time, and the speed I've got this on is okay for most of the work I'm going to be doing, so I'll leave it as is. Okay, that's my 5mm. Actually, I'm being silly, aren't I? Okay, nice flat bottomed hole there. We'll now move on to the tap. I'll start it off in the chuck. I'll knock that over to take that out of engagement. Stick a glove on so it's a bit more grip. That's in there nice and tight. Loosen that up and just push that in to there. Now this is a plug tap, but as anyone who's looked closely at a plug tap will know, it's actually got a very slight sort of 45-degree taper on the end, which takes up a good couple of millimeters. So again, I've taken that over to the grinder and I've taken off most of that, so there's a very, very small lead in on the end, and that's good enough to get rid of it all. So the next thing is I'm going to swap over to that. Just doing a chamfering job. One done. And stick that through there just to clean off the little burr at the end. Okay, and that should now screw it in there quite nicely, and then when I've got the nipple on the top, that will clamp down at about that point, so that's going to be quite nice. Okay, good. One done, 3 to go. Yes, putting these chamfers on makes it look nice, but more importantly, it makes it less sharp, because it doesn't matter whether it looks nice particularly, because it's going to be in the smoke box, and the only person to see it is me. But I'd rather not take my fingers off on a sharp edge. Check that with the 7.4. Good, that's going through nicely. So 1, 2, 3, 4. Now this one is a little bit too big. That's my first one, and I've actually played a bit too safe on that. So let's see if I can just take a little bit off the back of this one and get it down to a more acceptable length. Okay, see how that looks. Yeah, that's not too bad. For the purposes of this, that will be absolutely fine. And if I use this tool, then I'll cut across and put the chamfer on without changing tools. Right, happy with that. Chamfer the back, got that through. While that's in there, let's just give it a quick poke through with that to make sure there's no burrs. No, that's fine. And I'll just go around with the countersink bit just to give it a little bit of an edge. Okay. So 4 screwed fittings, 4 nipples and 4 union nuts. They are now ready to go on to this bar once it's been drilled. So I need to drill through that size to take the bottom of the nipples, silver solder it all up, and then silver solder the nipples onto the pipes into the superheaters elements themselves. So that's the next bit of the video, but for the moment that's the turning done. And I wish you good night, good day, be safe in your workshop and have fun. Bye from Dad's shed. And don't forget the tea.